Hi, my name is Lasse Munk. I'm a sound designer and creative technologist who work with stage performance, performing arts, but also immersive technologies such as VR, XR, etc. Today, we are going to talk about a piece of software called MaxMSP inside Ableton Live, then it's called Max4Live, and an extension from Ircam called SPAT, which is a piece of software that enable you to spatialize sounds. But before we begin, I want to say thank you to the Baltic Immersive Audio Network for encouraging me to making this video. We're going to use SPAT to create binaural sound synthesis. For this reason, I encourage you to use good quality headphones. That will make all the difference. Binaural synthesis is basically using computers to mimic the way that humans perceive direction and distance to an audio source. If you want to know more about the specifics of audio perception, then I just quickly searched and found a general introduction on this link here. If you haven't already, then put on your headphones and listen to this short production in binaural that I did using SPAT.
Et enfin, considérant que toutes les mêmes pensées que nous avons étant éveillées nous peuvent aussi venir quand nous dormons sans qu'il n'y en ait aucune pour l'or qui soit vrai, je me résolus de feindre que toutes les choses qui m'étaient jamais entrées en l'esprit n'étaient non plus vraies que les illusions de mes songes. Mais aussitôt après, je pris garde que, pendant que je voulais ainsi penser que tout était faux, il fallait nécessairement que moi qui le pensais fusse quelque chose. Et remarquant que cette vérité, je pense donc je suis,
Et remarquant que cette vérité, je pense donc je suis, était si ferme et si assurée,
que toutes les plus extravagantes suppositions des sceptiques n'étaient pas capables de l'ébranler.
Je pense, donc je suis.
sceptique.
Sceptique.
Je suis. Je jugeais que je pouvais le recevoir sans scrupule.
Et remarquant que cette vérité.
Pour le premier principe de la philosophie que je cherchais.
The device that we're going to create today is basically just like a pretty simple implementation of SPAT with the binaural configuration, with the HRTF 1040. And HRTF means an head-related transfer function. What it does is basically, if you imagine that I have been put inside an anechoic chamber, someone has put two microphones, one in each of my ears. I sit very still, and there's a loudspeaker in front of me. The loudspeaker plays a stimuli like a sine sweep or some noise. Then they move the speaker for certain degrees all the way around me, and every time the speaker is moved, the stimuli is being played again. And for each new direction, the sound inside my ears sound a little bit different because of the reflections from my pinna and from my torso, and also because when the sound is coming from one direction, it is closer to one ear than the other, etc., etc. All of this is more described in the link that I just posted before, and you can read a lot about it on the internet if you just write the HRTF or head-related transfer function and binaural synthesis. Basically, an HRTF profile is kind of like a bunch of recordings of directions that the SPAT engine can use to convolve an incoming sound signal, so it sounds as if the signal coming into SPAT is being played from a specific direction in space. Okay, so let's hear it. So I begin this demo just with playing two different loops I found inside Ableton Live. One is a break, And another one is a melody that kind of fits with the break. So right now the loops are just being played out of left to right, like you normally would if you made a mix. But let's try to listen to it while it's being played through SPAT, so we can change the direction of the sound sources. Let's start with the break. So I play the break. The break is now being played through this green bubble right here. And I can zoom in and out on the interface here. And when I use my mouse, I can move the bubble, and you kind of get the sensation that the sound moves further away or moves closer to the listener who is in here in the center of the space. And there are all these different configurations of functionality that each of these sound sources have. You can see there's one source, which is source number 1. There's another source, which are the tones, source number 2. In source number 2, I have the tones, or like the melody, and I want to use this to demonstrate some of the functionality that SPAT has. For instance, it has this Doppler feature. The Doppler effect is something you experience, for instance, if you hear an ambulance driving by you. When the ambulance is getting closer and approaching you, you will hear the volume rise and the pitch rise also. And when it's passing you and it's driving away, you will hear the pitch drop and the volume drop also. Let's try to hear this with the tones. So I enable Doppler effect, and I move the source number 2. You can see it's a bit difficult to see the green dot moving, but it's just my computer that has difficulties with recording video and do the synthesis at the same time. Let's try to hear it together with the break. You can also decrease the aperture. It means how much each sound source radiates into the reverberant space. So if it has a low aperture, you will have easier with hearing the direction of the sound source. See the aperture from sound source number 2 were shown by the white. So now it has a more narrow aperture, and I change it also for the drums. So it's easier now to hear the direction of each of the source. You can also hear that the high frequency noise in the drum signal makes it easier to hear the direction of the source. So that's a trick for making binaural production, to have like a very broad sound signal and also a lot of volume variation. Then the direction is much easier to hear. Also, especially with elevation. If you want to have an elevated sound, it's important that it has a lot of high frequency material above 8 kilohertz. So that was the general introduction. To download and install SPAT, first you visit Ircam's website. You need to create a user and to log in before you're able to download it, but it's free, so you can just do that. It's like you make a user any other place. You download it. I use Windows. You can use Mac OS or Windows as you want. When you have downloaded it, you can just extract the folder inside your Max8 folder. As far as I remember, also on OS X, it's located in your Documents folder. There's a folder called Max8. And if you drop the entire SPAT package inside Max8 packages, and maybe you have to restart Max, I'm not really sure, or at least restart Live and Max4Live, then you should be able to create a Max4Live device and use the SPAT externals. Externals is just a general term inside MaxMSP for using other code bases that makes you do something that Max out of the box doesn't allow you to do. SPAT is one of these packages. Max can see the package because you have set a file location. If you go to your options and file preferences, you can see you have set a user path, they call it. It's standard that Max8 packages folder is visible by the Max application. You can also install other stuff somewhere else on your computer and then make your own user path and set a path. I just tried to make my own folder and place SPAT inside that folder, and that didn't work. So I recommend placing it inside Max8 and packages. You can test that the SPAT install works by just creating a new track and creating a Max audio effect, for instance. Hit this small button here, which allows you to edit the Max audio effect. It can take a while for it to open. When the effect opens, it looks like this per default. There are some comments. It's these boxes. You create a comment by pressing the button C, and then you can write something. If you are a new Max patcher, then it's a good idea to use comments to kind of create notes for yourself around in the patch so you understand what it's doing. So basically what this patch is doing, you can see from these notes, is it's getting the audio from live. So if you think about this audio device, there is some audio coming here. It's coming inside this object. This is called an object, which has two outlets. This is outlet number 1, and this is outlet number 2. And these are two patch cords. So like small wires, kind of, you know it from a modular synthesis system. Actually, in many ways, it reminds you of modular synthesizers. So the left audio channel is coming through this yellow wire here, and the right audio channel is coming through this wire here. And because the input is just directly patched to the output, it means the audio coming from the left of the audio device is just going directly out to the right of the audio device. Kind of you would know it from any other audio devices, except that this actually does not do any processing. So it's a bit of a boring audio device. You can also see per default, there is this lighter gray area up here, and then there's a darker gray area here. So if I just save my device here, I call this test device or something like this. Test device. You can see when I saved that these comments that are up here, they are shown inside Ableton Live. If I save it here, you can see that they change space. If I move the right something underneath this device vertical limit, then it moves out of the visible area. It still exists inside the device, but you just can't see it from inside Ableton Live. I can make a new object by pressing N for new object, and then I can write the name of the object that I would like to make or create. For instance, a user interface object like a dial. Because this dial is specific to Ableton Live, meaning I can interact with it from within Ableton Live, it's called live.dial. It means that I can MIDI map it and I can use the clip automation, etc. The live dial looks like this. Max also has like a standard dial, But this dial is not able to be MIDI mapped or automated from within Ableton Live. It's made for when you are using Max in a standalone. For instance, if I want to make a user interface that I want to play around with from inside Ableton Live, it's a good idea to place these user interface objects inside the lighter gray area, like this. There's also a trick. Let's say that you have different user interface objects that you want to be able to see. You can mark them, you can right-click, and then you can add them to presentation view. Then you can go into presentation view down here, and then only the objects that are inside your presentation view is visible, which is pretty cool. To see the presentation view inside Live when I save, you need to tell the entire window that when the Max4Live device is loaded, you open in presentation view. When you do this, you see here, now it's the presentation view that is viewed down here. Inside Max4Live, there are basically two different states. There's one state where you are editing your device, and then you can log it, and then you can use your device. There's also a shortcut going in and out of edit mode, and it's on Windows, it's Control E. So I can make a comment. And I believe on Mac OS, it's Command plus E. So now I made my first patch. I can save it, Control S, like you would in any other software, and then I close it. Here is my working Max4Live device. If I want to do edits to this Max4Live device, I can press the Edit button. If I want to edit the entire patch, then I need to go back into the patching mode and out of the presentation mode. So now I can see everything that is inside my patch, and everything that is not marked by this red border is outside of presentation view, which is the reason that I could not see it when I saved the patch and closed it. You can see when I search for Max, there are 3 different Max devices I can create. There's a Max audio effect, there's a Max instrument, and there's a Max MIDI effect. A Max audio effect is a device that takes audio input and has audio output. That could be like the SPAT engine audio effect, or if you create a reverb that takes audio input or delay or something. Then there's a Max instrument. You create this on a MIDI track. It takes MIDI input and it has audio output. A Max instrument would be if you created like a synthesizer that you can play on a MIDI keyboard and it has an audio output. And then there is a Max MIDI effect that you also create on a MIDI track, which has MIDI input and MIDI output. It could be if you are creating some sort of random node generation or whatever. Okay, so let's try to make our SPAT device. I create an audio track. I create a Max audio effect. I open the Max audio effect. I'll just zoom in up in the left-hand corner so it's easier for you to see. These are the default nodes. I'll just delete those because I understand what they're doing. This is the audio coming from Live, and this is the audio output to Live. And this is the device vertical limit. What is above can be seen inside Live, and what is below cannot. Then, of course, you can use the presentation view to create your own interface. I just delete those. Now's the moment where we see if we have installed SPAT correctly. I'll just press N for a new object. I'll write SPAT 5, and then you see dot, and then it says SPAT, and then it has this funny object here. It's called tilde, and tilde is an object that transmits audio. You can also see the tilde on the audio input and the audio output. As you will see in a short while, there's also objects which does not have the tilde, which just transmit messages. I will explain that a bit further. For now, just write spat5.spat tilde, and this is the SPAT engine. You can see an input arrived and a lot of outputs. All Max objects have help files that you can look at. It's kind of like a manual for how to use the objects. It's quite cool if you right-click and you can open the object manual or help file. You can also use the shortcut Control-Shift-H, or on Mac, I believe it's Control Control Command H. Oh, yeah, I think so. So I choose it, say Control Shift H. The help file opens. And the cool thing about help files is that they are actually a working max patch with a lot of comments that describe how to use each object. You can also see there are different panes up here. So there's actually one called Binaural, which is kind of a go-to template if you want to work with binaural using SPAT. So I'll just choose this binaural template or help file. I'll press Control E to enter the edit mode. Then I can press Control A to select everything. Then I press Control C to copy. Then I can just close it. I delete my SPAT engine. And then I paste everything. While everything is still selected, I move it away from the plug-in, plug-out. So SPAT was originally created just for the standalone MaxMSP. So there are some objects in this help file which are made for standalone MaxMSP. For instance, this DAC. DAC is kind of the audio output the same way as the plug out is. The plug out is specific for Max4Live because it sends the audio back into Ableton Live, where the DAC means digital audio converter. This is the object that would send the sound directly to your sound card. But we don't want this because we want the sound to be routed out of the audio effects, out of the audio track and into our master track. So we can delete the DAC. Then we can choose the patch chords and just delete them by pressing backspace. And then we can patch the plug out to here. So you can, when I hover over the first output, the channel 1, then that would be the same as the left output or the left channel. My second channel would be my right signal. This is live.gain. If I wanted to make one myself, I could press N for new object. I could write live.gain, and then I would have the same object here. So it's just like a graphical user interface and a gain slider combined into one. Then I have my SPAT engine. Because live by default works with stereo buses, then I only want 2 inputs. And you can see here the default was 3 inputs. So I write 2 inputs here. I want to have 2 inputs into my SPAT engine. And now you will see that this input over here disappears. The internals 8 has something to do with the built-in reverberation machine. It's too complicated to go into now. But I want to have 2 outputs because I have my left signal and my right signal. And then I want to initialize my SPAT engine with the panning type of binaural. It's because SPAT can work with also multi-channels like a surround sound system, for instance. So there are different panning types that are specific to some speaker configurations, but we want to use the binaural configuration. When I press enter here, the input disappears. Poof. Now you see we only have 2 inputs, my left source and my right source, or source 2. And these are also something that it's like a sound player that you can use typically inside MaxMSP standalone. But we just want to have our source 1 coming from Ableton Live into Max4Live device and my source 2 into the Max4Live device. So we just delete these sound players and also the third sound player because it's not used. So I can patch my input here. It's my left signal and my right signal. So this is actually the basic setup for SPAT. It's quite simple. It's important that I save my patcher. I can go to File and Save As or Save, or I can just say Control S. I give it a name. Baltic Immersive Audio Network 2. Let's take a look at what else is in the patch. So there are some different links, for instance, to this patch, SPAT binaural. You can take a look at all these things if you want. Here's something about the SOFA conventions. The SOFA is like an organization or standardization for these HRTF measurements and the exchange of data. We don't need this. Then there are some comments. You can see before when we made a comment, I pressed C, write comment. See? But a comment can look different ways. If I right click and open the inspector, there's an inspector for all the objects in the patch. And an inspector is kind of like a setting. There's like different views. This comment box has the possibility of becoming a bubble like this. And then you can change the arrow direction like this, right? So these are also just comments. You can double click the SPAT engine to open the status window. So I press the lock here or Command E where you can use the patch. I double click and then something happens, right? We will go into this later. It's just for saying that these comments, is a comment and they try to tell you something. So we can leave this here to remember that it's possible to double click the SPAT engine. In the down right corner, there's also an object which has something to do with the Max standalone. It's something called a B patcher. It's kind of like a patcher within the patcher. You can open it to see it. So inside this patch actually looks like this, but when it's in the presentation view, it looks like this, and then you can open this patch inside another patch. So this patch controls like the audio hardware configuration. So if the audio processing is on and you get some information on how much RAM is used and how much CPU and what is your current IP address, etc., etc. We don't need this. We also don't need the Ircam copyright, blah, blah, blah. Then there's another B patcher, like a patch within the patch, that you can take a look at if you want. View looks like this, blah, blah, blah. We don't really need it. Then there are the settings for using different HRTFs. For the production that you heard before, I just used the HRTF 1040. There's also a very well-known HRTF called Kima, which, I don't remember the story of it. You can read about it on the internet, but it's like a HRTF that is generalized. So it's not really a measurement of one person. It's kind of like a mix of a lot of measurements. So it's very generalistic in a way. That's how I understand it, at least. Then there is a user interface for loading different other HRTFs, because it could be that the 1040 HRTF doesn't sound good to you. Then you can choose another HRTF if you want, but we are not really going to use it. These settings over here, they are too advanced. We don't really need it. We are not going to apply other SOFA files. We don't need this. The through object is a funny object because it's like a utility object, It doesn't really do anything. It just has like an input and an output inside a subpatcher. To explain what the through object does, I press I to make an integer, a whole number box, and another I to make another whole number box. I connect them together like this. You can see here the patch chords, they are gray, unlike the audio ones, which are yellow and black. Then the patch chords that transmit messages are gray. So a message is just like an event saying, now I want to transmit the number 100. And because this object down here, it understands the number 100, it displays the number 100. Let's say you have a lot of objects grouped together that are making a lot of mess inside your patch, like this, for instance. Then you can choose all of these and you can encapsulate them, or you can just press Ctrl-Shift-E. Encapsulate, it's kind of like moving them or packing them inside a new folder. When you encapsulate something, you create a subpatch. It's called a subpatch. You can give it a name. You can also call it Lasse or Kurt, for instance. It's a funny name in Danish, like this. So what happens is that the number 100, or like the number here, enters through this inlet here, enters this subpatch. It sets all these number boxes, and because this has an output connected to here, the output comes here and sets this number box here. So through is a funny object because it's a utility object that kind of helps you organize your patch in a way. You can see it just has an input and an output, but it doesn't really do anything. So that means that this, for instance, could be connected to this one, and you can delete this one. Okay, so we don't actually have so much stuff left from the template. We only have this other object, which is called spat5.oper. Oper is configured with 3 sources. You can see it's initialized with source number 3, so 3 sources. But so when we open it by double clicking it, you can see here there are 1, 2, 3 sources. But we don't have 3 sources, we only have 2 sources in our inputs here. So we need to configure the SPAT Oper with having 2 sources, like this. So now when I double click to open, I only have 1, 2 sources, the 2 green dots, like I showed in the beginning of the video. Me, the listener, is placed inside the middle here. So there's another subpatcher they called the listener movements. It's basically a demonstration that you can send some messages from this object called spat5 viewer and doing some math to it and outputting the information from the spat5 Oper into the spat engine. So spat Oper is like the control interface. And when you move this number here, you kind of move all the sources in relation to themselves. But we also don't really need that, so we can just delete it. Haha. Boof. Okay, then we would like to figure out a cool way to open spat Oper instead of double clicking it. So let's check out the help patcher to see if someone can tell us something about that. Luckily, there is someone who has made something cool. So we can just press Control E to copy this up here and Control C and close the help patcher and paste it. And you see there's an output here. And then I close the patcher, I press open, and then you can see the Oper is opening it and closing. Then you can see there's a floating window functionality, which makes it always on top, which is really cool because it's a control interface. It would also be cool to get an understanding of what kind of messages this spat5.oper is actually transmitting. And to understand this, we can try to open the help file again. And if we go to these messages here, you see there are these spat5.osc.view objects. Let's copy that. Let's paste it. You could also make your own with pressing N for new object. Press spat5.osc.view and then it would also appear. Then we could attach the object here and then press this bang or button up here. A button is basically just, when you press it, it's kind of like something that says do something. So we ask the spat5.oper to output whatever information it has inside itself. So like output its current state, and it outputs all of this information. So for instance, you can see, we talked about Doppler effect earlier. So you can see now the Doppler effect from source number 1 is 0. That means it's not enabled. And you can see here also the Doppler effect here, it's not enabled. It should be yellow if it was enabled. But let's try to send a message to spat5.oper to enable the Doppler effect. So to send a message, I press M, like me. And I construct a message that has like the slash and then source. And you can see it kind of already helps us here. There are all these different messages you can send to it. Source, and then I set the index, I set to 1. And then I want to have the Doppler, and I set it to 1. 1 means enable. So look at this yellow button here. So I enable it, and if I want to disable it, I can just set doubler to 0. Poof, like this. There's another way of doing it also with something that you're in programming called variables. So if I write source and 1 and slash doubler, and instead of writing 0 or 1, I write $1, then this $1, this part of the message will be substituted with something else. This is called a toggle. It comes when I press T. So I press T, this arrives. It's basically just a graphical user interface for sending ones or zeros. I press Command J to make it into a one-line object. It's practical. I close it, Control E, 1 when it's on, 0 when it's off. You can see this $1, it's substituted with the number coming in. So you can see when I turn it off, 0, on, like this, right? So this is a practical way of turning this effect on and off, except that we are making a Max4Live device and not a Max device. So there's a live specific toggle, which is called live.toggle. Looks like this, but it's basically doing the same thing. Like this. The cool thing about the live.toggle is that it can be automated from within Live. So now we have an interface for turning the doubler on and off, like this. And we can automate this from inside a live clip, for instance. It would also be cool to be able to control the position of these sources from within Live, from a live clip, using automation. So to get a bit of inspiration for what kind of messages you can send to spat5.opa, you can open the help file again, go into messages, and then a friendly soul has put this link into a help patcher called spat5.positions. When I press it, this one opens, and it so happens that you can set, for instance, X and Y coordinates. So let's copy this one and paste it into our patch and go back to the help file, and maybe just copy paste the link to the positions help file. Maybe we would like to go into that later. So it's possible to set the X and Y coordinate on this coordinate system here for the source. Let's set it to source number 1, for instance. And let's output the message source 1 XY, and then you can see the 2 coordinates here. So like before, we had a variable which called $1, but now we have 2 variables, one for the X position and one for the Y position. So it's a $1 and $2. So you see here the $1 is exchanged with this 0.8, and the $2 is exchanged with this 0.53. And when we see the OPA, we see the coordinate system here, and my computer is a bit slow, but you see that the green dot is moving, which is cool. If we would like to automate this from within Live, then we could set maybe 2 live dials. So a live dial by default outputs integers. Oh, I use a message to see what it sends. You can see it like this. And it's integers from 0 to 127, which is practical because it has something to do with MIDI very often. But we want to change the unit style to float because we want floating points. We don't need the range 0 to 127 because that would put the source 127 meters away. We would maybe just say -1 to 1. So when it's negative, it's -1, and when it's positive, it's 1. And we could do the same thing for the Y coordinate. If we want to change the name here, we choose the inspector, right? Or Control I. And we can change the short name to, let's say, X position. Let's call this Y position. Like this. Then we can output these 2 numbers. the Y position here, the X position here. And we see the result like this and like this. The pack has two inputs. What happens is that whenever one of these inputs are changed, then the output is a list, like a combination of the two inputs, but put together into one line. If I make it into a long message, you can see that this is the first moving and the second one changing. This is a message consisting of two elements. So this is the first element here, and this is the second element. So the first element will exchange the $1, and the second element will exchange the $2. Okay, so while we are still inside Max, I just want to take a quick detour, because it would be cool to not use the mouse to control SPAT all the time, and also not necessarily make automations. Maybe it would be cool to be able to control SPAT from, let's say, a tablet or a smartphone or something like this. And we already kind of touched upon something that is called OSC. When we created this object, it's called spat5.osc.view. So OSC stands for Open Sound Control. You can read more about it, for instance, on Wikipedia. And Open Sound Control is a protocol that is very similar to how you transmit messages over the internet. You can also transmit Open Sound Control just on a local network, or even just on the same computer. Use the network protocol to have different applications speak to each other in real time while running on the same computer or while running on different computers over a network. So OSC messages are often formatted like it is here with SPAT, with a slash and with a name and with some parameters. Just as an example, I've downloaded this application called Touch OSC, which is made for running on a tablet or on a smartphone or on a PC with a touch screen. What you can do is to create your own custom interfaces. So for instance, I've created this XY pad, which is very similar to this coordinate system here. I could also create like a fader, something like this. Then similar to MaxMSP, it's even the same shortcut. I can put it in run mode with Control E. And now I can use the touch screen on my computer, or if it was running on a tablet or on a smartphone, I would be able to touch the interface here. So I configured this XY pad to send an OSC message. It's called /XY pad, and then it has two arguments, the X coordinate and the Y coordinate. I configured Touch OSC to send data on the connection 127.0.0.1. It's the local IP for this computer here, and it's transmitting on the port 7001. And you see here it's called UDP, the protocol which is used. Inside Max4Live, I can make an object called UDP receive. I can listen on the port 7001, and I can see what is being received on the port 7001. I put Touch OSC into run mode, and you see here it has the /XY pad and the two arguments for the X coordinate and the Y coordinate. Now I want to strip the /XY pad from this message because I'm only interested in the two numbers. There are many ways of doing this, but one way is to make a route object and saying everything that follows the XY pad should go through here. So you can see now if I make a message called XY pad and then it goes there. But if it was a different message, let's say Peter Pan, and it enters the same place, then you see that what matches the XY pad exits here, and XY pad is kind of consumed by this object, and everything that doesn't match will exit here. So XY pad is consumed by the route object, and everything following it will be transmitted here. If it doesn't start with XY pad, it will exit here. So this means that these two numbers, the X and Y coordinate, will exit here, like this. Similarly to the pack object, there's something called unpack. It takes in a list of numbers and it separates them. So the x coordinate will be here and the y coordinate will be here. Now you see it says 0 all the time. It's because unpack by default thinks that it's receiving integers. So we need to tell it that it needs to receive floating points. Like this. Okay. Now we experience another problem because you see the range of these numbers are 0 to 1, both in the x and in the y direction. Now we wanted it to be from -1 to +1. So there are again many ways of doing it. I think you could also configure it inside TouchOC, but let's say you couldn't. Then one way of doing it would be to say I make a multiply object. I multiply with 2 and the point means that it's floating point. So I multiply with 2. Now the range is from 0 to 2 instead. This is 2, from 0 to 2. And now I can just subtract 1, and then the range will become from -1 to 1. I hold Shift while I drag the object, and then it releases the patch chord. I do the same thing for the y coordinate. And now you see that the ranges are from 1 to -1. This means that I have now successfully created a touch interface which is distributed through a network, meaning I could control this patch pretty much from anywhere. And if you look at and this scaling is basically the range, right? So you could also multiply and subtract something else to have a larger or smaller scale. There are also a scale object which could take in from 0 to 1 to -1 to 1, or from -4 to 4, for instance, and then it does the multiplication and scaling for us automatically, which is very smart, but it's also nice to understand what is actually happening. Now, these patch chords looks pretty messy, so you can say Control-Shift-Y, and then it automatically kind of makes it a bit more nice. You do it like this, then you see. You can also right-click and give it a color if you want, like this. Then it's easier to see where the patch chord is running. Let's make this into a device that we can use inside Ableton Live. We begin by selecting the objects that we wish to see inside our patch. It could be these objects, for instance. We add them to presentation view. We can remove this from presentation view. So this is the source 1xy. This was an example of enabling the doubler with it. And these messages open, close, opa window floating. You can also create comments, for instance. You can change the text color, something like this. You can add that to presentation view. Beautiful red color on a gray background. Maybe we do just a little bit like this. Design quality, top. You can add comments and add other functionality as much as you want. This is just for demonstration purposes. Now we just need to tell the patcher to open in presentation view. Like this, we save the patch. Close it. Now you can see that on the new device SPAT, we have these parameters exposed. We can open the opa, we can make it floating. Then let's try to route some sound into it. These are the sound examples that I used before. Instead of routing it through the old SPAT, I will just put it through the new SPAT. I will route these to the input of the new device. I will put the new device to monitor input. I pan the break all the way to the left. That way the input is coming through the left input of the device and going directly into the first source of the device. I pan the tones to all the way to the right, and so it goes to the source number 2. If you want to have a quick recap of how that worked, then you see the plugin here. This is the left signal and this is the right signal, right? So when you pan it all the way to the left or all the way to the right, then you essentially make it into a mono source that goes into either of these inputs. I made a beautiful reverb on my vocal also, because I have the input 1 which goes directly into the SPAT engine, so I can just say no input, but it still receives the break and the tones. Okay, I would like to begin to automate these parameters from Ableton Live. So a trick for that is to just copy and paste an audio clip into this receiving audio track. We won't get to actually hear the sound being played from this audio clip because the monitor is set to input and these 2 tracks here are transmitting into this SPAT device. But what we can do, we can still play an audio clip and just turn the volume down. It doesn't really matter, but just for like good practice. Then we can use the clip envelopes. So we can choose the device, the SPAT device, and now we have the parameters which are automatable. And you can see here it says X position, but we cannot see the Y position. And the reason for this is that we didn't set the Y position. We didn't give it a long name. We only gave it a short name. So we can call this Y position. And also for being able to be automated and also being saved with the live set, we need to set the parameter visibility to automated and stored. If we set it to stored or to hidden, it won't show up in the clip automation window. So we save this. And now we'll see that we both have the X position and the Y position available. Okay, but before we make these automations, I just want to show that it is possible for us to use this button to enable the Doppler effect. But because the Doppler effect is very much tonal, then I'll just change the break and the tones. So now the tones is on the source number 1 and the break is on source number 2. So when we hear this, we can enable the Doppler effect. And we can use these to move it around. Let's see if the clip automation works. Let's try it just maybe on the Y position. And my computer has a pretty hard time doing that. Okay, my computer does not want me to make these clip automations on the X and Y position for some reason, but in principle it should work. I have done it for many other applications before, but let's just for the sake of demonstration maybe do it on this live toggle which enables the Doppler effect. So I give the Doppler effect a long name and just a short name also. And you see here down on the parameter visibility, it was hidden before behind the image of me. Parameter visibility, it says automated as stored, so it's enabled to become automated by clip automation. I save it and I go to this, and now it says Doppler here, and you can see it's on off. So hopefully it won't go bananas when I'm trying to do this. So let's just play it just for the fun of it. I just changed these two again. And okay, and I play the Doppler on off, and you see that it's being automated by the clip envelope. It's on and then it's off. Another trick for binaural is that you have to remember that it's only stereo. So binaural is just stereo in some weird encoding, right? It was this convolution with this HRTF. So if I just delete the automation here, what I want to show you is that you can actually mix binaural encoding with something that is not encoded binaural and can sound cool. So let's say that if this was just like a normal stereo, I'll just put it to my master track instead of making it go through SPAT. Let's just give it another color for some funny reason. So I'll just put my drums in the center, and I put the tones into the source number 1 and open SPAT. In the center. So now the drum is it's just normal stereo, right? But you can still use the button to enable Doppler. And you can still make sound effects on the drums, like something like this one. So this is just a totally normal stereo drum with a binaural pad or melody on top of it. And if it's too heavy for the computer, the SPAT, then you can just make a new track and take the input from the SPAT and maybe just set the sensor only so it doesn't output to the master track. Record enable. And then you sample the movement. Now you have the recording of the pad movement as a loop, right? Encoded into binaural. Cool. Okay, one last thing I would like to show you is that you can actually also get SPAT as a VST. It's distributed by a company called Flux. And yeah, it looks like this. It's really crazy expensive, but there's a good news that somewhere around, where did I see? It was this, that they released some Ableton Live tools for free if you have Mac. So you can try that out if you are the lucky owner of a MacBook. And wow, there's Erve. He's a very cool guy. You should check him out. And yeah. So I hope you learned something, and yeah, good luck with SPAT and Max and all that stuff.